Imagine a world where wireless communication has the performance of fiber optics, bringing people closer together, making transportation easier with autonomous vehicles completely aware of their surroundings, devices that seamlessly communicate and collaborate to make your life flow better. At the center of this scenario is the device responsible for the sending and receiving of all the data, the antenna. To enable true 5G communication, we need to operate at a much higher frequency than today. And as the frequencies increase into the millimeter waves, the performance requirements for the antenna increases tremendously. At Gapwaves, we have a groundbreaking new way of designing and manufacturing antennas, holding the key to enable this future of high-frequency communication. Today's 5G antennas are based upon traditional PCB technology that require a lot of energy and yet have a very limited range, meaning a higher antenna density. Hence, scaling up 5G with today's antenna technology would have an enormous environmental impact and would crowd our urban areas with big antennas. The automotive industry races towards safer mobility and semi-autonomous vehicles by using advanced radar technology. But the market has a hard time supplying the demand of high-performance, affordable, and reliable solutions. But we hold the key, a totally new approach to designing and manufacturing waveguide antennas, bypassing the previous high requirements on tolerances and complicated processes. With Gapwaves technology, we create antennas that are cost-effective, scalable in mass production, and combining the range of 4G with the speed of 5G. Within telecom, our antennas would double the range, allowing for coverage not only in urban areas, but also in the countryside. They would only require a tenth of the energy consumption compared to traditional PCB antennas, leading to a significantly lower environmental impact. Simultaneously, it reduces the requirements of all other components within the antennas because of the lowered heat emission. The future benefits of 5G-enabled vehicles are vast, but our antennas also have positive implications from a safety aspect if applied to radars. Our antennas can double the range and increases the field of view of radars in providing far higher resolution and details. This allows for a compact design, which is easier to build into the vehicle and enables enhanced safety features to not only be a premium car feature moving forward. With our antennas, autonomous vehicles would be safer, no matter the lighting or weather conditions. To increase the frequency and meet the requirements of 5G, the industry is looking into waveguide antenna technology, basically a metallic rectangular tube in two halves through which radio waves can travel with low losses. The electrical and magnetic fields from the wave induces electric current along the walls of the waveguide, resulting in high requirement on tolerances to avoid power and efficiency loss. Gapwaves replaces the method of using metallic walls with a metamaterial surface called an artificial magnetic conductor. A unique structured surface consisting of pins has the similar to a perfectly sealed wall, completely preventing the waves from propagating in undesired directions without even having to have contact around the waveguide. This allows for an effective waveguide to be built with dramatically relaxed tolerances, meaning it can utilize existing manufacturing technologies. This groundbreaking artificial magnetic conductor was invented in 1988 by the Gapwaves founder, Simon Shieldall. His invention was clearly ahead of his time, but now that the wireless technology has caught up and is actually requiring this invention, we have a production-ready solution in the midst of implementing it into the massive and complex world of automotive and telecommunication. We are on the doorstep of the future, and we hold the key.